Rahim. Today we are solving question number 6, exercise 3.1, its part 2. As we proceed in the last part 1, now we are going to prove that the part 2 solution. Right hand side is equal to lambda A plus mu A. So first of all we find lambda A is equal to lambda into A matrix 3 by 3 A11 A12 A13 A21 A22 A23 A31 A32 and A33 as we take this in the first part. So this is equal to lambda A11 lambda A12 lambda A13. As I tell you in the last, if a scalar multiply by a matrix, then that scalar will multiply with the each element of matrix or each entry of the matrices. So lambda into A21 lambda into A22 lambda into A23. So lambda into A31 lambda into A32 and lambda into A33. Now mu into A is equal to mu into A11 A21 A31 A12 A22 A32 A13 A23 and A33, same as we take in the last. So it is multiplied by a scalar mu. If a scalar multiply with any matrices, then we have to multiply that scalar with each and every element or entry of the given matrix. So this is equal to this is equal to mu A11 mu A12 mu A13 mu A21 mu A22 mu A23 mu A31 mu A32 and mu A33. We have this here, set number 1 and set number 2. Now we are adding number 1 and number 2. We get lambda into A plus mu into A is equal to lambda A11 lambda A12 lambda A13 lambda A21 lambda A22 lambda A23 lambda A31 lambda A32 and lambda A33 plus mu A11 mu A12 and mu A13 mu A21 mu A22 mu A23 mu A31 mu A32 and mu A33. We got from here lambda A11 plus mu A11 lambda A12 plus mu A12 lambda A13 plus mu A13 lambda A21 plus mu A21 lambda A22 plus mu A22 lambda A23 plus mu A23. Then the last lambda A31 plus mu A31 lambda A32 plus mu A32, and last one is lambda A33 plus mu A33. Now we got the common lambda mu A11 is common here. Similarly A21, and similarly every term has a common, so we take its common. That is equal to lambda plus mu into A11 lambda plus mu into A21 lambda plus mu into A31. Similarly lambda plus mu into A12 lambda plus mu into A22 and lambda plus mu into A32. Similarly lambda plus mu into A13 lambda plus mu into A23 and lambda plus mu into A33. Now we are going to take lambda plus mu common from the whole matrix is equal to lambda plus mu as a common. So we got here A11 A21 A31 A12 A22 A32 A13 A23 and A33. Now if we look at this is equal to A, so is equal to lambda plus mu into A. So lambda A plus mu A is equal to lambda plus mu into A, which is equal to right hand side. So left hand side is equal to right hand side. Now its third part is lambda into A minus A is equal to lambda minus 1 into A. Its solution is given as we find in the last part, lambda A is equal to lambda A11 lambda a12 and lambda a13. Similarly, lambda a21 into lambda a22 and lambda a23, lambda a31, lambda a32 and lambda a33. Now lambda a minus a is given as lambda a11, lambda a12 and lambda a13, lambda a21, lambda a22 and lambda a23, lambda a31, lambda a32 and lambda a33, minus A mean A matrix, A11, A12, A13, A21, A22, A23, A31, A32 and A33. So this is equal to lambda a11 minus a11, lambda a12 minus a12 and lambda a13 minus a13. Similarly, lambda a21 minus a21, lambda a22 minus a22 and lambda a23 minus a23, lambda a31 minus a31, lambda a32 minus a32 and lambda a33 minus a33. Which is equal to lambda minus 1 into a11, lambda minus 1 into a12 and lambda minus 1 into a13, lambda minus 1 into a21, lambda minus 1 into a22 and lambda minus 1 into a23, lambda minus 1 into a31, lambda minus 1 into a32 and lambda minus 1 into a33. Now we are taking lambda minus 1 common from the last matrix we got. That is equal to lambda minus 1 into a11, a12, a13, a21, a22, a23 and a31, a32 and a33. This is equal to A. Look at this. This is the matrix A that we start with, lambda minus 1 into A. So lambda A minus A